Hey everyone, welcome back to 1.8 Absolute Value Inequality Notes. We are going to talk about how to rewrite an absolute value inequality as a compound inequality, meaning instead of splitting equations up into two equations, we're going to split inequalities up into two inequalities and put the word and or in between them. Then we're going to solve them, put our answer on a number line, and interval notation is making its way back today. One thing before I jump into this next table is I did an awful job at making sure that there was enough, or there were the correct numbers with number line. So what we need to do really quickly is I'm going to put -3 at the end of every number line, and then I'm going to make 0, and then I'm going to make 3. -3, 0, 3. 3, 0, 3. Sorry about that, guys. I can't fix it and reprint it, otherwise, because you guys all have papers already. So, moving on. If we want x to equal, absolute value of x to equal 3, you should know by now that there are two solutions to this, 3 and -3. Okay? Because both of those are 3 away from 0. Okay? On this one, we want x to be exactly 3 away from 0. Okay? Then, when we move on to the absolute value is less than or equal to 3, that means that x is 3 or closer away from 0. So if we want that distance to be less, then we're getting closer, not further away. Less distance means closer together. So we're going to start at our 3 and -3. And if we want it to be closer to 0, then we're talking about this part here in between. And the interval notation for this would be -3, 3. And I'm putting brackets around both of them because they are both closed circles, because there was an equals to involved with that less than or equal to. Then I left you guys some space underneath to write. And what I want you to do underneath here is make a couple of notes with me that less than, I can spell, makes a sandwich. Okay, and I'm saying that because and is what we want in between these. Okay, so we could write this as x is greater than -3 and x is less than or equal to 3. I should have said equals to on the other one too. Then moving on to the next one, if we want the distance to be greater than or equal to 3, then x is 3 or further away from 0. So this time, instead of going in between, we want to go to either side. So instead of being from -3 to 3, we have to do -infinity up to -3, bracket, and then 3 to positive infinity. And this is where it starts getting to actually be pretty important that you write your interval notation in the right order, otherwise it's going to look confusing. And then whenever you have two intervals like this, you're going to put a U in between them. Okay? And I call this great or than, because we are going with an or situation here where they go opposite directions and we have to include both intervals. Okay, going back to what we learned in 1.2, and is when you're looking for the overlap like we have in the middle, or is when you're looking for either or, and you can go on either end like we did on the right side. Okay, so I know I spelled greater than, I did that on purpose to call it great or than to help you remember that that one is the or. Okay, and I'm going to kind of go over this again in the next table if you look down just a little bit. For absolute value inequalities, both of the less thans became ands. Okay? And if you want to make a note underneath, you can. I know we just wrote this. Let me write that in a better place. I call these the sandwiches because they go between two numbers like this. Right? And then over here with your greater thans, you have your or. Okay? And that means that these are going to go opposite directions. So something like this. I'm going to fix the one on the left. I don't know why my arrow is weird today, guys. Sorry. Okay, so together versus opposite directions. Okay, less than goes closer, so they're going together, and that makes the sandwich. Greater than means you're going away from zero, so they have to go opposite directions. Okay, so here are just some steps. I know these are on your papers too. I just wanted to go over them. First thing is isolate the absolute value. Get it by itself, always. Because you might have to multiply or divide by a negative, so you don't want to start doing any of the other steps until that's done. Okay, then you're going to rewrite it as a compound inequality. This step is the most important, and that's where you need to decide if you're going to use an and or a or. Okay, and remember that you're always going to switch that inequality symbol if there's going to be a negative a. So you know how you flip it if you multiply or divide by a negative? This time when you go to do the negative version, like you did with the equations, you're going to switch that. I know that doesn't make a whole lot of sense to you just yet. I will explain that again. It's more of a reminder. And then you're going to graph them both on a number line, write your solution in interval notation. If it's less than, you're going to make the sandwich and look for and. If it's greater than, you're going to look for or, and you're usually going to need two intervals. Okay? So this is just kind of a reminder piece that you can always go back and reread if you need it. These are kind of the words I usually say as I'm solving, and I want them on record for you. So here we go. We have the absolute value of 2x plus 10 is less than 8. Step 1 is to isolate. Okay? Is that absolute value by itself? Yes. Done. Then we need to split it up into two inequalities. And I'm just going to write compound. So I'm going to keep the same symbols and everything. 2x plus 10 is less than 8. And then I'm going to come over here and do 2x plus 10 is greater than negative 8. So if this was an equals, we would have done 2x plus 10 equals 8 and 2x plus 10 equals negative 8. When you switch to the negative one, you have to switch that symbol. Okay? So this symbol right here is where we are flipping. Okay? And then we need to go ahead and solve these. So I'm going to subtract 10. 2x is less than 8 minus 10, negative 2. Moving over here, I'm going to subtract the 10 also. So I like to solve both of mine at the same time because you're doing the same steps always. Negative 8 minus 10 is negative 18. So I just do it on both inequalities at the same time, and then I don't have to think through everything twice. Now I'm going to divide by 2. X is less than -1. X is greater than -9. So I don't have to flip those symbols at the very end because guess what? I'm dividing by 2, not -2. Okay? So I need to go from -9 all the way up to 1, -9, -8, -7, -6, -5. Okay, I count mine out. Honestly, guys, I don't really care as long as I can see where -9 and -1 are on your number line. X is less than -1 means that we're going to have an open circle because there's no equals to, and it's going to head this way. And then X is greater than -9, it's going to head the other way. So we're really just highlighting this area in between them. Okay? This problem started out as a less than, meaning that it's going to be a sandwich in between from -9 to -1. So our interval notation is -9, -1. They should both be in parentheses. The terrible parentheses will leave it. Because there's no closed circles. Okay. Isolate, write your compound inequalities, and solve. When you go to do your compound, the one always flips that has the negative. Okay, I know I did not explain that very well when I was on the last slide because we weren't on an exact question. Okay, so step 1, isolate. There is something outside on this one. There's a -7. So let's add that 7 to the other side. -3 plus 7 is 4. Notice I'm keeping the same symbol for right now. Okay, now the absolute value is all by itself, so your next step is going to be to go ahead and make it compound. So keep one exactly the same, 3x plus 2 is greater than 4, and change the other one to a -4, and as you flip this sign, also flip the symbol. Flip the sign, flip the symbol too. Goes together. And then we're going to solve both of these. Minus the 2 from both sides. 3x is greater than 4 minus 2, 2. Minus the 2 from both sides on the other inequality as well. -4 minus 2 is -6. And then we're going to divide by 3. And I know somebody's probably wondering this. Are these always going to use the same steps? Yes, because this side of the equation, the side with the x, is the same. So you don't really have to worry about whether or not it's going to be the same every time, because it is. So we're dividing by 3. Ooh, icky fraction, 2/3. That's all right, we can just leave it. X is greater than 2/3. Dividing by 3 over here. X is less than -6 divided by 3, -2. Okay. So I'm going to go ahead and put -2, -1, 0, 1, 2 on my number line. This says x is greater than 2/3, so I'm going to put a circle here. You can write 2/3 or draw an arrow like this if you want to. And then it's greater than, so it's going to go to the right. Then my x alone is x is less than -2. So I'm going to go to -2, open circle because there's no equals to, and I'm shading to the left because that's less than. Okay, and notice how this greater than inequality naturally turned into one's going the opposite direction. Okay, that's going to happen sometimes. Then, last but not least, my interval notation goes from negative infinity on the left all the way up to -2. And then I'm going to put a parentheses around that because it's open. And then it starts again at 1. Oh, sorry, not 1, 2/3. And goes to positive infinity. You do not have to write the plus on that infinity. You do need to write a u to combine them in between. Okay. Next one. 4x is greater than or equal to 8, or the absolute value of 4x is greater than or equal to 8. Okay, this one is already isolated. There's nothing outside. So we're good. Then we are going to set up our compound inequalities. 4x is greater than or equal to 8. And 4x is less than or equal to -8. And now we are going to divide by 4 on both sides to start solving these. Okay, remember when I put that -8 up there, I switched the symbol because I switched the sign. Come on, okay, there we go. Divide by 4, divide by 4. Everything's getting divided by 4. X is greater than or equal to 8 divided by 4 is 2. X is less than or equal to -8 divided by 4 is -2. Okay, so greater than or equal to 2. I need to put 2 somewhere on my number line. I'm going to head towards -2. Close circle since it's or equals to. And greater than goes this way. Then -2 less than goes this way. Okay, this is also a greater than, so meaning we're going to have 2 different intervals on this one. The first one is going to be, and let's go ahead and jump this up a little bit. Sorry about the bell, guys. Definitely finish my video. And lunch is starting. Okay, so I have negative infinity all the way up to -2 on my left side. Then on my right side, I'm starting up again at 2 and going to positive infinity. Putting my little u in between, and there you have it. Okay, I'm going to do one more example that is going to be a less than or equals to. I don't remember if it's or equals to. And then I'm going to leave the last 2 for you to either go copy from my PDF if you want to, or ask me about in class. I may even start class with them on Monday. All right, so it is a less than or equal to. Isolate is my first step. Minus that 5 to the other side. Absolute value of x plus 6 over 3 is less than or equal to 3. 8 minus 5 is 3. I'm still not done isolating yet. I gotta get rid of that 3 on the bottom. And the opposite of fractions, which is division, is multiplying. Boom. No more fraction. Everybody cheers because we all hate fractions. Then the absolute value is now isolated. So my next step is to go compound. All right, that means I have x plus 6 is less than or equal to 9, as it is already. Then I'm going to keep the x plus 6, change the other side to -9, and as I change that sign, I change my inequality symbol to go the other way. And my last step is to solve. Okay, the thing by the x is a plus 6, so we're going to -6. That is the opposite on everything. x is less than or equal to 3, and x is greater than or equal to -6 plus -9, -15. Okay, this would be a good one to just plot -15 and 3 down on your number line, because that's definitely not going to stretch that far unless you go by 2s or 3s or something like that. Okay, I need to go less than or equal to 3, so that's a closed circle, and I'm heading this way. And then for my -15, closed circle as well, because it's greater than or equal to, which heads this way. So the part we want is where they overlap, okay, which is right there. Sorry, I gotta go rid of my circle a little bit. From -15, comma, to 3, both of them getting brackets because they're both closed circles.